So today we're going to be talking about enthalpy change, and I'm going to cover some tips you need to know when answering enthalpy change questions. Hi everyone, it's Jeremy from the classroom, and let's get started. So when you come across an enthalpy change question, alright, some of the common questions will be, in terms of bonds broken and bonds formed, alright, explain why a certain reaction is exothermic or maybe endothermic, alright, or sometimes in MCQs they might tell you, does breaking of bonds absorb or release energy? So it can get a bit confusing. Now what I always like to do is this. Whenever I come across an enthalpy change question, the first thing I will do is I will sketch an energy profile diagram. Okay, so let's assume we look at the first one. Okay, we talk about methane undergoing combustion and why is it exothermic. So when methane undergoes combustion, alright, it forms carbon dioxide and water. And to balance, I'm going to put a 2 there and a 2 there. Alright, so it's balanced. Okay. Now, so in terms of bonds broken and bonds formed, why is it exothermic? This is a typical 2-3 mark question. Now, first things first, let's sketch an energy profile diagram. Okay, so this is always what I do. Whenever I come across an enthalpy change question, I will sketch the energy profile diagram. For an exothermic reaction, energy exits. Alright, so energy is lost, right? So if energy is lost, we will end up with less energy. Okay, so the analogy here is this, if you don't understand, alright, imagine you're walking along the road and you are losing money along the way. Okay, you start from home and you're walking to school, along the way you lose money. When you get to school, you will end up with a lot less money than when you started. Alright, okay, so same thing. For an exothermic reaction, energy is lost as the reaction happens. So your reactants will start with more energy, your products will end up with less energy. For an energy profile diagram, we will draw the hump in the middle, the curve in the middle, alright, okay? And let's fill it in. So here we have methane and oxygen, CH4 and 2O2. And here we have carbon dioxide and water. Okay, so now, this part going up here, okay, let me just draw it very quickly. Okay, this going up here is actually the amount of energy that's absorbed to break bonds in your reactants. Okay, energy absorbed, ABS for short, to break bonds. Now you see what's happening here is this, at a molecular level, alright, so methane, I'm just going to draw here at the right hand side, methane is CH4, okay, and oxygen is O double bond O. Okay, now this part here in green here, okay, this going up here, the energy is actually being absorbed to break all the bonds in methane and oxygen. Alright, so much so that once this is done, we end up with C and H and H and H and H without the bonds because all the bonds are broken. And we end up with 2 molecules of oxygen, basically 4 oxygen atoms. So all the bonds are broken. So energy is absorbed to break bonds. And on the other hand, alright, once that is done, alright, the atoms are going to rearrange themselves and they're going to start forming bonds to form your new products. So when bonds are formed here going down, alright, this part here, alright, going down, right, energy is released, alright, to form bonds. So we're going to form carbon-oxygen bonds, we're going to form hydrogen-oxygen bonds, alright, okay, basically carbon dioxide looks like that, C double bond O, and water looks like that, alright, so we're forming, once again, we're forming the carbon-oxygen bonds, and we're forming the water, alright, okay, so there are 2 moles of water, let me put a 2 there, sorry about that, and so we're forming a total of 4 OH bonds. So how do I make use of this energy profile diagram to answer the question? So once again, they ask you to explain why it's exothermic. So very simply, what you need to do here is this. Look at the energy absorbed and look at the energy released. Notice how the energy absorbed to break bonds is less than the energy released to form bonds. Alright, okay, so just by looking at the diagram, we can see clearly energy absorbed is less than energy released. Also, we can see very clearly that the enthalpy change is negative because there is a loss of energy. So if you put all of that together, you will be able to answer the question correctly. So the question is this, right? Explain in terms of bonds broken and bonds formed, right? I'm going to craft an answer here. The energy absorbed to break bonds in CH4 and 2O2 is less. Once again, lesser, more, right? So less than the energy released to form bonds in CO2 and 2H2O. Enthalpy change, is negative, hence reaction is exothermic. And this is a simple 2, sometimes 3 mark question. Okay? And once again, if MCQ, all right, second runner, part B, if you're ever confused if bond breaking absorbs or releases energy, just look here. To break the bonds in the reactants, there is an increase in energy, energy is absorbed. To form bonds, energy is released. All right, okay, so an analogy I use in class sometimes is the making of Lego. All right, so imagine you have a Lego, all right, to pull it apart you need energy, right, so energy is absorbed. And when you click it together, it's usually a sound, and sound is produced, energy is released, all right, so that's the analogy I use in class. And this also works whether or not it's endo or exo. So very quickly, let me just sketch an endothermic reaction where energy absorbed, energy enters, so the products have more energy. Similarly, this is the amount of energy that is absorbed, energy that's released. And notice how the energy that's absorbed is more than energy that's released. Enthalpy change is positive, and therefore your reaction is endothermic. All right, so I'm going to say again, whenever you come across an enthalpy change question, sketch an energy profile diagram, answer the question. It will help you in your next test or exam. I hope you learned something new today, and I'll see you next time.